Okay, so today we're going to look at law of cosines. Yesterday we looked at law of sines, and this is kind of a little bit of a continuation of it because we're trying to figure out different parts of a triangle now. So this first part, we're just going to try to derive the law of cosines. Number 1 says, given triangle ABC with lengths A, B, and C, find DB in terms of X and A. So we can see DB is up here in this triangle. Specifically, A being the full side and X being that smaller side, C to D. If we just take A and we subtract X off of it, that would give us that side from D to B. Number 2 says, write two equations using Pythagorean theorem that relate H with the sides of triangle ABC. So we can see that because there's this line drawn in here, labeled H, it actually splits our triangle into two right triangles. So one of them would be x squared plus h squared equals b squared. And the other one would be a minus x squared plus h squared equals c squared. And those would be two Pythagorean theorems that relate with h. Part 3 says solve each equation from step number 2 for h squared. So there on the left side here, we would just subtract x squared, right? That would get h squared by itself. And then that would be equal to b squared minus x squared. On the right side here, we can subtract off that whole a minus x squared to the right side, and that would also get h squared by itself. So we would have h squared is equal to c squared minus a minus x squared. Because both expressions are equal to h squared, we can now set them equal to each other. After that, we're going to solve for c squared and then expand and simplify it. So if we set them equal, we would have b squared minus x squared equals c squared minus a minus x squared. From here, it says solve for c squared, so we're actually going to add that a minus x squared to the other side. And that would give us b squared minus x squared plus a minus x squared equals c squared. It's asking us to expand and simplify. What it's asking us to expand is this a minus x squared, right? We would have to FOIL that, a minus x times a minus x. FOILed out, that would give us a squared minus 2ax plus x squared. So what we have is b squared minus x squared plus a squared minus 2ax plus x squared is equal to c squared. And then the last step here, to simplify this thing, we can see that there's a negative x squared and a positive x squared, so those two things would cancel. And we would be left with b squared plus a squared minus 2ax is equal to c squared. This is kind of like the basis for the cosine law of cosines. We would just need to fill in the cosine here. So step 5 says write an equation for cosine of c in terms of triangle ADC and then solve for x. So let's look back up at triangle ADC. We can see ADC is this left triangle up here. And we want the cosine of c, so cosine would be adjacent side divided by hypotenuse. So the cosine of c is really x divided by b. So we would say cosine c is equal to x divided by b. And if we solve that for x, we would just multiply b on both sides. So now we have b cosine of c is equal to x. Step 6 says, now substitute this value for x into the equations from step number 4, and you have not necessarily proven, but derived the law of cosines at this point. So we plug this x into our equation above, and that would give us b squared plus a squared minus 2ab cosine of c, right, because this is where x used to be, and then that's equal to c squared. And there is your law of cosines formula. This specifically uses A and B if we had those sides, and if we had angle C, we could figure out side C. So if we know other information, we can write other law of cosine formulas. Like what if we knew A squared plus C squared, right? Then we would say minus 2AC cosine of B, so the cosine between A and C. or the angle between A and C, and then that would be equal to b squared. And then the other option for the law of cosines would be b squared plus c squared minus 2bc cosine of A is equal to a squared. Although you can write this formula in many different ways, the biggest thing you need to know is that the angle that's in the cosine is between the two sides that we have, and then the side opposite is always opposite of the angle, or the side on the other side of the equal sign is opposite of the angle that we have in our formula. With law of sines, you can find missing values in triangles with angle, angle, side, angle, and side, side, angle. In yesterday's video, I accidentally erased angle, side, angle because I wasn't thinking. But in the homework, you saw some examples of angle, side, angle with law of sines. So there's two of these triangle congruencies that are missing, and one of them is side, angle, side, and the other one is side, side, side. So if you have those, then you would be able to use law of cosines. So the different reasons to use these things, if you have side, angle, side, you're probably looking for the last side of a triangle. If you have side, 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 you're probably looking for angles in the triangle. For the law of cosines one, if you have angle, angle, side, you're probably looking for a side. If you have angle, side, angle, this is a little bit harder. You would need to find the third angle, and then from there you're looking for a side. And then side, side, angle is probably looking for another angle in that question. So these are all the things that you can find if you have these information using law of sines and cosines. Example 1 says find the value of C in the triangle below. So this is a really nice one because we have side, angle, side here, which means we just need to find that last side using our law of cosines. So we plug in, we're going to say 20 squared plus 15 squared minus 2 times 20 times 15. And then cosine of C, right, that angle that we have right there, so cosine of 73 is equal to C squared. These questions are the nicest ones because we literally just pull open our calculator. So I'm going to grab Desmos right here. And then we just type in that whole left side. So 20 squared plus 15 squared minus 2 times 20 times 15 times the cosine of 73. Double check that I'm in degree mode here. Yep. And that would give us 449.6 basically. You want to try to not round too much in the middle of these problems because when you round a lot, it's going to take your answer further and further away. But we have this 449, and then we can just square root that number, right? Because we square root both sides because it's C squared is what it's equal to. So the square root of 449.576977166 gives us 21.2 is equal to C. And that's how you do that first example. For example number 2, it says find the measure of angle A in the triangle below. So this is an example of side, side, side. Notice that was side, side, side. It's finding angles in triangles. Setting this one up is a little bit more difficult, but remember the angle that goes in the law of cosines is always opposite of the angle that it would be, or the side that it would be equal to. So this is telling me we're going to be equal to 11 squared because we want to find the angle opposite of 11 squared, or of 11. So we say 11 squared is equal to, and then just our law of cosines, 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of the angle that we want. From here, we cannot just plug all of this into our calculator and click enter because we can't add the left side of this to the right side of this because it has the cosine stuck to it. So instead what we need to do is we need to find what is 9 squared plus 13 squared. And then I'm also going to find what 2 times 9 times 13 is. So 9 squared plus 13 squared gives us 250. And then this is 2 times 9 times 13, so minus 234 cosine of theta, the angle that we want. And then we can even do 11 squared, which is 121. And so from here, we're going to subtract off the 250. So 121 minus 250 gives us negative 129 is equal to negative 234 cosine of theta. Now we can divide off that negative 234 from both sides. So divided by negative 234 gives us 0.551 equals cosine theta. And then we take the inverse cosine of that to figure out what our angle is. So we have 56.5 degrees is equal to theta. And then the last thing on these notes is Heron's formula. So Heron's formula is just a formula to find the area. You use this with triangles that have side, side, side. That's when you can use Heron's formula. So it looks like this. Area equals the square root of, nice big square root, is going to be S, and then S minus A times S minus B times S minus C, all of those in parentheses, where A, B, and C are all the sides of a triangle. And then this S over here is called the semi-perimeter. And then your question probably is, well, what is the semi-perimeter? We can write a formula for that. It's almost what it sounds like. It's literally just half of the perimeter. So if we took A plus B plus C and divided it by 2, that would be S. So for our last example right here in triangle ABC, we have A, B, and C, so side, side, side. It's asking us for the area, so we can use Heron's formula. And then we would say we need to find S first. So 23 plus 46 plus 41, all divided by 2. This is going to give us 55. I just have that memorized from doing this note so many times. And then we can plug it into the area formula. So area equals the square root of, and then 55 times 55 minus 23 times 55 minus 46 times 55 minus 41. So just all of those side lengths. And then you just type that into our calculator. So let's throw that into Desmos. Square root of 55 times 55 minus 23 times 55 minus 46 times 55 minus 41. And that is going to give us an area of 470.9. And then we just say units squared, since there were no units on this one. And yeah, that's really all the notes for today. If you have questions, just let me know. I'm trying to think. Work-wise on these questions, it's really just show as much work as you need to, all right, because there's a lot of writing in these problems. So if you have a question, if you're not showing enough work, just let me know. But yeah, have a great day.